Hello, this is Ms. DB, and in this video we're going to learn how to solve absolute value equations. This is from Chapter 2, Section 6. So, absolute value is the distance a number is from 0 on a number line. So, we use these straight up and down bars to show absolute value, and the absolute value of -5 is 5 because it's 5 units away from 0, and the absolute value of 5 is also 5 because it's also 5 units away from 0. So the absolute value of a number is always positive. We don't talk about negative distances, so we don't have a negative absolute value. For any non-zero absolute value, there are exactly two numbers with that absolute value. So 5 could be the absolute value of 5 to get that number, or the absolute value of -5 to get that number. So we can write it in, using algebra, we write the absolute value of x equals 5. And then there's two solutions for that. Most of the problems that you're going to do with absolute values will have two solutions. And we will find those two solutions by writing two equations. So we'll take the absolute value signs away and write two different cases to find the two solutions. Now sometimes they'll just be the opposite of each other, like that example, 5 and -5. But many times you'll get two different numbers that are not the opposites of each other. Like you might get 2 and 9 as the answers, or -7 and 3. So they're not always just going to be the opposites of each other. So here's how we do these problems. There's these steps. First of all, we're going to use inverse operations to isolate the absolute value expression. So if there's something added or divided from the absolute value expression, we will undo those operations first. Then we will rewrite our result, what we have, as two cases. We'll take away the absolute values and write a positive case and a negative case. And then finally, we will solve each of those two cases to see what we get for an answer. So this is the very simplest problem you could have. I don't even know if there's any this simple on your worksheet. We already know the answer is going to be 12 and -12, but let's go through those steps. So the first thing you would do is make sure that this is isolated, meaning there's not a 3 times the absolute value of x or the absolute value of x plus 7. It's just the absolute value of x. So that step is already done. We don't have to do it. The second step is to write our two cases. And our two cases is when we take away the absolute value signs and we write x equals 12. That's the positive case, that it's equal to the positive of that value. And the negative case is when whatever's inside the absolute value would be equal to the opposite of whatever's on the right side. And in this case, like I said, this is the most simple possible thing you could have. It's just going to be 12 and -12. But usually, those two cases, you're going to have more work to do after you write those. And then this is a reminder that you should check both of your answers back in the original equation and see if you get a true statement. All right, so here's one. This is more like what your problems on the worksheet will look like. Our first step is to isolate the absolute value part. That's this, the part that has the bars around it. We cannot undo the +7 yet because that is inside this is a type of grouping. So that's locked together. But we can undo the multiply by 3 that's out front. So we're going to divide both sides by 3. And on the left side, this will cancel. And I'll be left with the absolute value of 7. The absolute value of x plus 7 is equal to 8. Now we write our two cases. The first case, the positive case, is when we drop the absolute value signs and we just write x plus 7 equals 8. And then we solve that equation. The second case is when the absolute value is dropped and we have x plus 7 equals -8. So then we solve both equations, subtract 7, subtract 7. On the first case, we get x equals 1. On the second case, we get x equals -15, not -1. So again, this is an example where these are not the opposite of each other. We get two completely different answers. We can check those by plugging them back into our original. Let's see, if we plug 1 in here, we'd have 1 plus 7 is 8. 3 times 8 is 24. Yep, that works. Let's try plugging negative 15 in. So let's check our answers on this problem. We have x equals 1, so I'm going to put that back into the original equation. So we'd have 3 times the absolute value of 1 plus 7, and I want to see if that is equal to 24. So 1 plus 7 is 8, so I have the absolute value of 8, but the absolute value of 8 is just 8. So I want to see, does 3 times 8 equal 24? It does, so then this works. Now let's check our other solution, which was negative 15. So I have 3 times the absolute value of negative 15 plus 7, and I want to see if that is equal to 24. So 3 times the absolute value. I do the work inside the absolute value and get negative 8. And then I have to take the absolute value of negative 8. The absolute value of negative 8 is positive 8, so I get 3 times 8 is 24, and that one also is right. Now, what if I had said, oh, one answer is 1, the other answer must be negative 1? Would that check as well? Is that also a solution? Let's just check this one up here. I would put the negative 1 in for x, and I want to see if that's equal to 24. Now, when I do the work inside the absolute value bars, I have negative 1 plus 7. That's 6. And the absolute value of 6 is 6. So I have 3 times 6, which is not equal to 24. 3 times 6 is 18. So negative 1 is not a solution. If you had written that, you would get this problem wrong because it doesn't work. It's not true. So make sure that you are finding both numbers separately and not assuming that they will be the opposite of each other, and also that you're checking your work. All right, let's look at another example. In this one, remember our first step is to isolate the absolute value part, so we need to undo the minus 3. That's not inside the absolute value bracket, so we can go ahead and undo it by adding 3 to both sides. When we do that, we get the absolute value of x equals 7. Now we write our two cases, and our two cases are going to be x equals 7 and x equals negative 7. This is one of the short and easy ones when you have just the absolute value of x and there's nothing added or subtracted or multiplied or divided inside the absolute value sign with it. So these are our answers. You can absolutely stop at this point. You don't have to write them in curvy brackets like they're doing here on the slide. Now this one, we're not going to have such a simple one because there's something else inside the absolute value sign. So this one, there's nothing to undo from the absolute value part does not have anything added, subtracted, multiplied, or divided to it. So we're going to go ahead and write our two cases right away. One case is just 8 equals, a positive 8 equals x minus 2.5. And the other case, we put a negative on the other side. So we have 8 equals x minus 2.5, or negative 8 equals x minus 2.5. And then we solve each case. These answers will not be the opposites of each other. So we will add 2.5 to both sides in case 1, and we get 10.5 for x. For case 2, we also add 2.5 to both sides, but now we have negative 8. So negative 8 plus 2.5, and you can check with your calculator if you need to, is negative 5.5. So once you have your two values of x, you can stop and say that that is your answer. You don't have to list them like that. All right, so here's some problems from your worksheet. Number 2, I said that these would be the two equations. This would be case 1 and case 2, or you can call them the positive case and the negative case. And we will solve each of these equations and see what you get for x. There'll be two answers. In number 3, we first have to start by isolating the absolute value part. So let's subtract the 2 that's outside the absolute value signs from both sides. That leaves us with the absolute value of 3x equals 6. Now we need to write our two cases. Our case 1 is just drop the absolute value signs and write 3x equals 6. Our case 2 is you drop the absolute value signs and you put a negative on what it's equal to. So 3x equals 6. You divide both sides by 3, and we get x equals 2. For case 2, we divide both sides by 3, and we get x equals negative 2. So my two solutions are 2 and negative 2. If you want, you can write your two solutions in, these are the curvy brackets, not regular parentheses, because then it looks like a coordinate point. It just means this is the set of solutions. All right, let's do number 5 because of the fraction. It's already has the absolute value sign is already isolated, so I can go ahead and just start with case 1 and case 2. So case 1 will be my positive case. I just have to drop the absolute value signs. And other than that, I write exactly the same thing. In case 2, I drop the absolute value signs and say that it's equal to the opposite of what I have over here. So I would solve this by subtracting 1/2 from both sides. X equals 1 minus 1/2. Well, if I have a whole sandwich and I take away 1/2, I'm left with 1/2 a sandwich. In case 2, I will subtract 1/2 from both sides. And negative 1 minus 1/2, that's the same as negative 1 plus negative 1/2. The rule says that if you're adding integers or real numbers and you have the same sign, you should add these and take the sign of both. So my answer would be negative 1 1/2, or negative 1.5, or negative 3/2. Those are all ways of writing the same answer. And those are the two solutions to this problem. Now, not all absolute value equations will have two solutions. All the ones we did so far would, but if the absolute value expression equals 0, there's only going to be one solution. And if you ever have an absolute value equal to a negative number, that is not possible. So then you don't even have to solve that. You can just write no solution if that happens. And remember, you can't have a negative absolute value because where absolute value is referring to the distance from 0 on a number line. So how could you have a negative? There's no such thing as a negative distance from 0. Let's look at this example. Now you see there's equal to a negative, but we're not ready to say that there's no solution yet because of this minus 8 over here. It's not just the absolute value of something equal to a negative. There's this. So we need to isolate the absolute value part. So we'll undo the minus 8 by adding 8 to both sides. And when we do that, we will get 0 because negative 8 plus 8 is 0. 0 equals the absolute value of x plus 2. If you ever have an absolute value equal to 0, there's only going to be one case because you can't do a positive case and a negative case for 0. All you can do is write your one equation and then solve the one equation. So we subtract 2 from both sides and we get x equals negative 2. And this is an example where you'll only have one solution for your absolute value equation. Erase that there. Okay, now let's look at the other kind of example. In this one, we have to isolate the absolute value equation, so we subtract 3 from both sides. And when we do that, we get the absolute value of x plus 4 is equal to a negative number. Now that's not possible because absolute value is referring to distance from 0, and distance is always positive. So as soon as you see that you have an absolute value equal to a negative number, you stop and write no solution. So this problem here has no solution. So you have several of these on your worksheet. Now some of these will have one solution, some of these will have two solutions, and some will have no solution. So you're going to solve these, and that's what you'll get. Now you're not going to just tell me how many solutions it will have. You actually have to answer the question. So right off the bat, this one is the absolute value of x plus 4 equal to a negative number. This one's going to be no solution. Let's look at number 11. If we subtract the 1.5 from both sides, we'll get the absolute value of 2.8 minus x is equal to 0. So this one is only going to have one solution, but we still need to find what that one solution is. There won't be two cases because you can't do a negative 0 and a positive 0. So we just go ahead and solve this one. This one is a little tricky with the negative x here. So when we undo this, we subtract the 2.8 from both sides. and we have negative x. That minus sign here becomes a negative x equals negative 2.8. If you prefer, put a 1 here, and then you can go ahead and divide both sides by negative 1. So x is equal to negative 2.8 divided by negative 1 would be a positive 2.8. So number 11, there's only going to be one solution. Let's just start solving number 12 and see what we're going to get for how many answers you're going to get. So we're going to have 5 times the absolute value of x plus 7. I subtracted the 14 from both sides to get negative 6. And then I would still have to divide both sides by 5 to undo this multiply by 5. So I'll have the absolute value of x plus 7 is equal to negative 6/5, which is kind of ugly. But then I can stop and say, wait, it doesn't matter how ugly it is because this is a negative. And the absolute value of x plus 7 will never equal a negative number. So you can just write no solution. And I'm kind of happy that we didn't have to deal with this negative 6/5 and add 7 and so on, or subtract. So that's how you would do those. And then the last part of your worksheet is just a couple word problems. In number 13, we have Barry's walkie-talkie has a range of 2 miles. And he's traveling on a straight highway and is at mile marker 207. Write and solve an absolute value equation to find the minimum and maximum mile marker from 207 that his walkie-talkie will reach. So I already wrote the equation for this one for you. It would be the absolute value of x minus 207 is equal to 2. So we will write our two cases, and then the other case would be x minus 207 equals negative 2. And what we get for our answers will be the 2 mile markers that Barry will still be able to use as walkie-talkie. So in number 14, it's a very similar question. A brick company guarantees to fill a contractor's order of 1,500 bricks, 1,500 bricks, to within plus or minus, so a range of 75 bricks. So we're going to write it very similar to this one. We'll put the absolute value, and the x will be what we're looking for to find the maximum and minimum amount of bricks, and we will subtract the 1,500 that the contractor ordered, and that will be equal to the range. And then if you write the two cases from this, you'll find out how many the minimum and maximum bricks that you can order is. And then the last one just says, do you agree with the statement to solve an absolute value equation, you need to solve two equations? Maybe I'll put in this little thing to help you think about this one. Do you always need to solve two equations? I mean, sometimes you do. We just did a bunch of those. But we also saw sometimes where you don't have to use two equations, like if it's equal to 0. Or in the case of equal to a negative number, we didn't even have to write any equations. Or solve any equations. We just said no solution. All right, thank you very much. Have a wonderful day, and remember to ask for help if you get stuck.